Hey, it's Jim. Got a really cool story here with great conversation with Gabriele Provinciali. And he is an engineer and a solutions architect and works at Oracle in Rome. And he tells a really interesting story about the team over there in 2018, a really hot summer where they constructed a city, a model city, basically, a smart city, essentially, where they did it out of, Lego bricks, Raspberry Pis, IoT edge sensors, Arduinos, all this stuff. And they connected it to, obviously, Oracle Cloud. And it's basically a demonstration of the different features that basically it's a way to show off the features of Oracle Cloud. And this was very successful. They had a great time doing it. They took it out on the road in Europe, and they actually won some awards for it. And other people started to construct similar cities because they published a spec, and people started to actually make their own cities. And then the pandemic came, and everything changed. And so they decided to sort of revisit the project and see what they can do to, instead of having simply a smart city, but had to have a safe city. What features would you add to the city to make it safe? Like, for instance, social distancing features, like if there are too many people in a specific area, the sensors would detect that. Or if hand dispensers need to be refilled, or these types of things. And so he tells this story about this whole evolution, and he's also has documented it in 3 long and technical articles, so you can go out and build your own safe city, basically. They call it Proxima Safe is the name. And aside from the 3 articles, there's also a video. So I'll have links to all this so you can see what this thing looks like visually. A lot of fun. We also talked about trends in software development and community development and universities. He likes to do a lot of university work, which is something I also love to do. And I found out that he's also from Sun Microsystems. So I keep on tripping over Sun people at Oracle. Imagine that. So that's about it. It runs about a half an hour. Hope you like it. Talk to you next time. Gabriele, welcome. Welcome to the program.
Thank you. Hi, Jim. How are you?
I'm doing okay. Doing okay. We've exchanged some Slack messages and some emails over the last few months or so, and people on the team have been telling me that I should have a conversation with you. You're in Rome, Italy, which is where my grandparents were from. Actually, near there, but they're from Italy, and so they tell me on the team that I should talk to you about this series of articles that you published recently on the website, Proxima Safe. It's like an Oracle lab series of articles, basically. And there was lots of building with Legos and Raspberry Pis and things like this. But it started out to be Proxima City, and then it evolved to be Proxima Safe. And so, yeah, that's what I wanted to talk to you about. I like talking to people who build things with their bare hands, preferably. Not necessarily always just writing code, but actually hammers and nails as well. So
yeah, well, it was a pet project developed in August in the Eternal City, and August in the Eternal City means hot and humid. So, the office was our sanctuary. And there was a bunch of people building up Legos, building up sensors, and try to imagine, a new version of Rome. Because Rome is basically a museum, a living museum. But as a citizen, we would like to share the museum part with the modern city part, which sometimes is not very compatible. So we try to imagine, new stuff, like not flying cars, but something that we always dream of. Like, for instance, booking a parking lot from your home before you go to work. And in order to do that, we just invented lots of use cases. Some of them were just scrapped because they were impossible to do. But it was a mixture of building Legos in order to give a practical aspect of the city itself, and of course mounting hardware, trying to hide hardware under the Legos and try to program the stuff in order to automate what we could automate in terms of machine learning, in terms of sensor, IoT, edge stuff. And then, of course, using cloud to do essentially to receive events from the city in order to let the city adapt to certain situation. And that was good. It was a success for the team, the innovation team in Rome, until the pandemic. Because it was a huge model, like 3 meters by 3 meters.
Wow.
And then with the pandemic, no more office, no more demos. So I thought, we need to reuse that for the new world. And the new word was, making maybe the closed environment safe. So this is why the transition from a smart city to a safe city and safe environment. So we reused the sensor. We bought a regular sensor over shops, online shops, and something like that, and we programmed it. And we made something more compared to the previous city model. We found a way using the sensor protocol or Internet of Things protocol, open source like MQTT, to send the results of the analysis back to the environment, to the edge environment. So something could happen physically, like if too many people can pass, are not allowed to pass through a corridor, we could switch on a red light. Or if sanitizer gel ends in a specified environment, we could raise an alarm to the maintenance people in order to fill it up. So that there are new use cases for the new world, the new shape of world that the pandemic basically helped to shape. And it was it was quite fun to design it, to program it, and to write about it, because everybody wants to be a writer, and when you have to describe what you do in terms of technical articles or columns, right, you have to use some scientific or quite standard language. And of course, I tried to be funny in what I wrote and let the people have fun, because this project is basically oriented to students, to professor, to anybody that wants to be involved in building something like and I wrote about it, like the Iron Man suitcase. So you're a suitcase, you bring out all the sensor, you mount it, and you have a portable lab in order to study some funny things that could happen.
That's interesting. A couple of things you said there. So yeah, it's like a lab environment. But tell me about the team that actually built this. So start off with the first phase, the smart city. This is in 2018, right? Tell me about the team that you work on that actually put this together.
Yeah, it was the innovation team, which was made of. So
is this a cloud team? People. Is this a?
It was an hybrid team, made of cloud. There were different personalities. For instance, our boss was really into Lego, so she designed all the landscapes, the bridges, the houses. And in the original design, if you go inside the house, with the light, you can see that the house is populated. I mean, it's not empty. So she is, terrific in doing this. And then there was people more oriented to data, people more oriented to machine learning, deep learning, in order to, for instance, analyze the images that the city was sending to the cloud. And other people more interested in doing IoT stuff, more people interested in doing Java stuff. So there was a place for everybody. And it was, I think, one of the best things I did in almost 40 years of career.
How long did it take to build it?
The first prototype was made in a month.
Okay.
So during August, we projected, okay, we can have, a viable or an MVP, a viable version in 2 months, maybe in October. But I think the 29th of August, we made the first demo.
Yeah, because you mentioned the summertime. Yeah, I think you mentioned the summertime.
So about 4 weeks, 5-6 people. And, it was a pet project, and then it exploded because everybody wanted to have, Proxima City in the office. So I think, number of models were something like more than 25 around the world, including Red Wolf Shores.
Wow. And you mentioned also that it was a part of like some maker fairs?
Yeah, we participated to Maker Faire in Rome. And we couldn't stop the people in trying to get in the city. We needed to just, put some fences in order to protect the city because people was getting crazy. I think we won, a prize, more than a prize, because people was stopping for the Lego. Because you see, Legos moving, or the train moving, stopping. There was also, a small robot called Cosmo that was impersonating, a citizen that could drive through the city. So people, came from the Lego, but basically, at the end of the demonstration, they had a clearer. A more clear idea of what was the cloud and cloud functions in order to provide this kind of services.
Interesting, really interesting. Why do you think it? You said it 25 or so additional models. Why do you think people were so interested in? So are these separate models? So people created their own?
Yeah. We exported the general model with the bill of materials and maybe some kind of houses.
Okay, but you didn't have the series of articles though that you just read that you just wrote.
Actually, we wrote while we were mounting the model in Red Wolf Shores. We wrote the manual in order to, because there are a lot of moving parts in terms of hardware, software, Legos, and interactions. And I think they made it because it was looking nice. And when we talk about software, we talk about something abstract.
Right.
When we talk about the cloud, it's even more abstract because it's the cloud. Right. When you can see something that happens in a physical model that goes to the cloud, the data are analyzed, and you can see directly, the feedback from the cloud into the CD or into the the portable laboratory. You can see, the practical effect of software, hardware, and cloud together. So this is why the people was, making it, because it was a good way to represent the data analysis in the physical world.
Yeah, that's one of the reasons why I was so interested in this, because I used to work in the construction industry in New York, and so for years and years and years, I was around people, some of them highly technical, like architects and designers and stuff, and even machine operators. These people had been working with their machines for 40, 50 years. They were highly, highly skilled craftsmen. But they were actually constructing something that you could see. You could see it come together, whether it was a house or I did, small construction. So, housing developments. But I was on a few commercial sites to see these guys, working with steel and stuff, and huge 100-ton cranes. Those are non-trivial pieces of equipment, and it does have this very visceral effect. And so, when you showed me your stuff, I said, oh, that's construction right there. I mean, that's a project. That's project management. That's construction. And obviously, you're adding the modern sort of version of that, which is all the software and all the systems.
Yeah, you have to consider that as a software engineering, as a part of a software engineering team, we respect the construction word. We call it the real engineering, because things in the physical world, things are designed, most of it, to last.
Yeah.
In the software world and the cloud world, everything is designed to change rapidly or as fast as possible.
Right.
So, making the two things or trying to converge the two things is something, I think, almost impossible. And I repeat, huge respect for people that, build things to last.
Right. So tell me about yourself a little bit. How because you fit into this team, you guys built this and then you evolved it. What's your background? What did you study? What are your interests in order to get involved in this?
Yeah, I come from the telecommunication world. And I spent more or less the first decade in telco, writing software for, the big machines that allowed connections in the 80s. And then I became an IT guy for the rest, for the subsequent decades. And then I'm facing, I'm rapidly approaching the end of the fourth decade, and there are some things that have changed completely, but something that most of the time stay the same. Think about the passwords. My first password was hello. Now it was back, at the start of the 80s, because there was no problem in doing that. Now think about that, and think about the software development life cycle, how much is different. But nevertheless, there are some things that never change, like the matrix terminal, the green on black stuff. There was a time in which IDEs are conquering the world, but most of the programmers will use same stuff we were using 40 years ago. So something changed, something really changed, and there's something still subjected to the individual experience that a programmer can make during their growth.
Interesting. So you also mentioned a little bit earlier when we were talking that you do get out to speak at events, before the pandemic, and you work with students as well. What's that like? Because I did a lot of community building. I came from Sun Microsystems. That's how I got into Oracle. And
yeah, me too.
Oh, okay, cool. Wow. See, there's still a few of us around. I didn't know that. And so, we did I was on the Open Solaris project. And so we did a lot of community building at universities because we were starting the project new. We were releasing large amounts of code, 10 million lines of code, and hoping to grow into new areas. We did a lot of visiting of universities. And I found it very interesting working with students. They were a lot younger than me, obviously a lot younger than me, but their thinking process was very, very different. And this was enlightening to me. Very smart. I couldn't really talk to them for that long. I would do a talk, I would be talking about the community. You had to get involved in user groups and things like this. And these are all CS majors in some university in China, and they'd come up afterwards and ask me kernel questions. It's like, okay, I'm not going to get very far on that. But what's it like working with students?
Well, I think it's I would do it for free, actually, because it is something that I started actually in Sun, because I was working in Sun, Italy, and I was sent to Garcia Avenue in Sunnyvale in the Silicon Valley to get some info about a specified project that was called previously Oak, and then became Java. So I think I was more or less the first in Italy, together with an ex-colleague of mine. And so we went there. We started to tinker with this new programming language. And from what I remember, I spent the subsequent 6 months in attending universities, even prestigious universities like Normale di Pisa, which is very cool, and just explaining Java and showing how to the programming model and how to do stuff. And from there, it was I think the best part of my job. Not only because it's a way to affirm your ego, but it's it's a good way to have new ideas from people that is heavily in the learning process,
right?
And is not as not a crystallized idea of a programming or over use cases. So the more you are able to explain things, the more you have to study in order to be prepared, and the more you need to open your ears and be susceptible to new ideas. So this is why I think that it is something that keeps you younger.
Yeah, many people don't realize that you just can't stand in front of like a classroom of graduate kernel developers and sort of just tell them things. They're going to come back with some of their own really interesting problems. It's very much a give and take, I think, and there's very much a learning process that goes both ways. And you have to know your stuff. You really do have to know your stuff.
It's a good incentive to be prepared. Right,
exactly. Yeah, I think that's a simpler way of saying it. So you're on this team. It's very hot. It's 40 degrees in Rome. You're building this city. Obviously, the pandemic, comes. You switch it over to be more on the, to focus on more pandemic related things in terms of safety issues for the city. You wrote these 3 articles, which are very comprehensive. I'll actually put, obviously, links to everything. They're very long, very detailed. So somebody can go out and replicate this, very, very easily with this data. And so, what's next? I mean, what happens now with this? Where things are sort of opening up. Conferences are starting again in Europe and in the West. Do you have plans to continue this with the team, or what's next for this project?
Well, my ambition is to, and we started actually this process, is to make this model suitable for universities and students. There is a university in Italy which has already implemented, the physical model, which is Università del Sannio, is down in the south, and they were very clever because they they bought it basically, and they use as a demonstrator. They use that to teach students, and they use that to do research activities. And we are going to replicate this, but what I would like to absorb from the field is new use cases, especially in the machine learning stuff. I think that there are a lot of stuff that needs to be done. And in this case, I believe that the subject is the man, the human being. And, using machine learning, using IoT and the combination of two can really help us to be more human, let's say, to express ourselves even in tough time like this. Because I'm still home. The office is still closed. Slowly we are seeing some activities outside, but we need to live with that. And I believe that the combination of a smart city, with a safe environment and a good way to teach stuff will make young people eager to help and invent new stuff. So I use always this metaphor. We produce some mechanical pieces with Proxima and ProximaSafe, and we would like people to mount these pieces and invent new stuff. So it's a meta model in order to bring up new models.
And a lot of the technologies that you used in terms of the software technologies are open source. So I'm just wondering, maybe the open source community, have you had any interactions with the open source community about this?
Well, yes. As a matter of fact, most of the edge stuff is based on open source because, sources are completely available. And that shorten the gap between the idea and the making. And the physical making of the idea into something viable, because you can. The web is literally full of examples that you can grab, but in this case, the best idea will be the most appreciated one, because it's not only software, but it's software, let's say, put the software in context. Like if the physical environment is a university, you will have a certain shape of the environment that you need to control or you need to check. If it is an open environment, so open air, you will use some other stuff. If there is a combination of two, you need, different pieces of software. So I believe that, the open source example and literature is not a problem in 2021. Ideas, it's always something precious. And I believe that the students and, of course, teachers and professors are more interested in the idea and the way to make it, feasible. There are open source stuff. There are also, some industrial stuff like the stream analysis. So it's a combination of words. I believe that, diversity, it's something that surely make your ideas better. So if you use a combination of open source and industrial products that maybe are there since 10 years ago, can be both useful in order to develop new ideas and making something better.
Yeah, it's interesting. I was talking to Dale Doherty. He's the founder of the whole Make, actually, the Make magazine and the whole Make move. Mm-hmm. I actually met him years ago in Silicon Valley when I was at Sun, and he echoes a lot of things that you're talking about in terms of students, in terms of openness and building things that matter in the real world, using whatever technology you can, whether it's hardware or software. but building it in the real world where it has very physical, tangible. And so that's when people said I should talk to you, I said, okay, cool, but it's like, now I know why, because I can see the passion that comes through for this process of building, so it's very interesting. So, all right. So it sounds like you have a plan. You're going forward. Is there anything that we've left out? Anything that you want to add?
Well, I believe that the next stage will be to make the edge world and the cloud world more homogeneous with the with the adoption of the ARM processor. I think that's a big hit, because most of the development boards and so or microcomputers such as the Raspberry Pi, they work on ARM, but they are built around the ARM concept. What about if the cloud was entirely, ARM, or a mixture of ARM and AMD and Intel? That could be, a major breakthrough also in consumption reduction in terms of heat. There are a lot of stuff to be involved with, which is not only software and hardware, but also points out some sustainability issues. So I think this is something that we should definitely point out.
Excellent. Okay, cool. All right, Gabriele, it was nice meeting you virtually here for the first time. I'd love to meet for some nice wine and food in Rome someday, soon.
Yeah, I really need it.
Since we both came from Sun, we can swap some Sun stories, and it'd be good. Thanks a lot. We'll talk to you soon.
Okay. Bye, Jim.